sklearn, Gaussian process, kernels, CompoundKernel. A deep dive. The CompoundKernel class in scikit-learn is a powerful tool for building complex kernels for Gaussian process regression (GPR). It allows you to combine multiple kernels using basic arithmetic operations, enabling you to model intricate relationships between your input features and target variables. Understanding the basics. Kernel functions in GPR. Kernels represent the prior belief about the relationship between input features and the output. They define the smoothness and structure of the underlying function, influencing the shape of the predicted function. CompoundKernel. The CompoundKernel allows you to combine multiple simpler kernels using arithmetic operations. This creates a more expressive kernel capable of capturing complex relationships. Key values in YAML for CompoundKernel. Let's consider a YAML configuration for a CompoundKernel with two components. YAML. Kernel. K1. Kernel RBF. Length scale 1.0. K2. Kernel constant kernel. Constant value 1.0. Combination method sum. Here's an explanation of each key and value. Kernel thus defines the overall kernel. It's a compound kernel composed of two components, K1 and K2. K1 thus represents the first kernel component. Kernel specifies the type of kernel for K1. Here, it's RBF, the radial basis function kernel. Length scale. This parameter controls the length scale of the RBF kernel. It determines how quickly the kernel decays as the distance between input points increases. A smaller length scale implies a more localized influence, while a larger length scale allows for more global influence. K2 thus represents the second kernel component. Kernel specifies the type of kernel for K2. Here, it's constant kernel, a constant kernel. Constant value. The value of the constant kernel. It determines the baseline variance of the output. Combination method. This defines how the two components K1 and K2 are combined. The available options include sum. This simply adds the two kernels together. Product. This multiplies the two kernels together. Linear. This combines the kernels as a linear combination, allowing for a weight to be applied to each kernel. Building complex kernels. The CompoundKernel can be used to build complex kernels that capture intricate relationships. Some common examples include combining RBF with a constant kernel. This allows for a base level of variance plus localized smoothness from the RBF kernel. Adding periodic kernel to RBF. This can be used to model data with periodic trends on top of a base level of smoothness. Multiplying different RBF kernels. This can model different length scales for different input features. Capturing specific local influences. Practical applications. The CompoundKernel is versatile and can be applied in various scenarios. Modeling spatio-temporal data. Combining kernels for spatial and temporal variations. Mixed feature types. Handling both numerical and categorical features by using appropriate kernels for each type. Capturing nonlinear relationships. Combining kernels to model complex relationships that go beyond linear models. Example usage. Python. From sklearn, Gaussian process import Gaussian process regressor. From sklearn, Gaussian process, kernels import RBF. Constant kernel. CompoundKernel. Define kernel components. Kernel 1 RBF length scale 1.0. Kernel 2 constant kernel constant value 1.0. Create CompoundKernel using sum. Kernel CompoundKernel kernel 1 kernel 2. Create Gaussian process regressor. GPR Gaussian process regressor kernel. Fit and predict with the model. GPR. Fit X-train. Y-train. YPRED GPR. Predict X-test. Considerations. Kernel selection. Choosing the right kernel components and their parameters is crucial for achieving accurate predictions. Computational cost. Complex kernels can be computationally expensive, especially for large datasets. Hyperparameter optimization. Tuning the parameters of the component kernels is essential for optimizing the model's performance. In conclusion, Compound kernel in scikit-learn provides a powerful way to construct sophisticated kernels for Gaussian process regression. By combining simpler kernels using arithmetic operations, you can create highly expressive models capable of capturing intricate relationships in your data.